Hello chemistry fans, and welcome back to Chemistry 1032 problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'll be guiding you through this problem today. So without any further ado, let's jump in. Alright, the air in your tires is 32 pounds per square inch. In the morning, your tires are a cool 15 degrees Celsius. However, by 5 p.m., your tires have warmed to 31 degrees Celsius. What is the pressure inside of your tires at 5 p.m.? Alright, so this question is basically asking us how will the pressure in our tires change as the gas inside warms up? And for this kind of question, we're going to assume that tires are rigid. They don't give with less pressure. So they are more or less rigid, but not quite perfectly rigid. But for this question, we're going to assume that the volume of the container doesn't change. So we'll see. We'll see how this question works out. Let's do that again, guys. That was stupid what I just said. All right, so cut. Do it again. Chapter 8, Problem 3. Hello, chemistry fans, and welcome back to Chemistry 1032 problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'll be guiding you through these problems today. So without any further ado, let's take a look. The air in your tires is 32 pounds per square inch. In the morning, your tires are a cool 15 degrees Celsius. However, by 5 p.m., your tires have warmed to 31 degrees Celsius. What is the pressure inside of your tires at 5 p.m.? All right. So again, these kind of questions, there's just a lot of words going on up in here. You don't have to worry about them too much. You just need to pull out the pertinent, important information. So the air in your tires is 32 pounds per square inch, PSI. So PI equals 32 PSI, pounds per square inch. In the morning, your tires are a cool 15 degrees Celsius. So TI equals 15 degrees Celsius. However, by 5 p.m., your tires have warmed. So it's getting hot out there. TF equals 31 degrees Celsius. What is the final pressure in PSI? So it wants to know what the pressure in our tires is if the temperature warms up just a little bit. Well, this is Guy-Lussac's law. Guy-Lussac says PI over TI equals PF over TF. Very similar to Charles's law, but instead of volume, it's pressure. And just like in Charles's law, you can invert or flip over the equation and no harm comes to you. There you go. So either one of those formulas is correct. So we want to isolate PF. We need to have PF all by his lonesome. So multiply both sides by TF. So PF equals PI TF over TI. That's the expression we're going to have to use. And this is a gas law question, so make sure you convert these two temperatures to Kelvin. Okay, bust out our calculator real quick. 15 plus 273 equals 288 Kelvin. 31 plus 273 is 304 Kelvin. Okay, so now we have our temperatures in Kelvin. So let's plug in our numbers. PI, 32, multiplied by TF, which is 304, divided by 288, which is TI, initial temperature. Let's get out another color marker. Make sure the units we don't want cancel, leaving us with a pressure unit, PSI, pounds per square inch. So that is a pressure unit. Now, before we do any number crunching, let's check for logic. The way Guy-Lussac's law works is that Guy-Lussac has stated that pressure and temperature are proportional. So if temperature goes up, the pressure will go up as long as the volume of the container doesn't change. So in this question, we're at 32 psi, and we've increased our temperature from 15 to 31 degrees. So the pressure should also go up. So let's take a look at that. 32 multiplied by 304, divided by 288. 33.7 or 34. The final pressure will be 34 pounds per square inch. All right. Now, if you have any trouble doing this kind of question, or you still have issues, please contact one of the many tutors here at the Academic Success Center, or come on by a professor's office during normal office hours. And with that, I'd like to wish you good luck and good chemistry.